a particular talk that you gave with Amit Sharma, whom you mentioned earlier. So the two of you gave a talk in 2021, last year, on the foundations of causal inference and its impact on machine learning. And so this talk is a bit over an hour long, and it's tremendously popular. So at the time of recording, it has over 13,000 views, which is amazing for such a technical topic. And in that lecture, you provide 4 key steps of causal inference. Could you elaborate on those 4 key steps for our listeners on the podcast?
Of course. The 4 key steps. So it's modeling your assumptions, identification, estimation, and then refutation. The first one, assumptions, is about capturing your knowledge about the system that's going to guide the rest of the analysis. This ends up looking like, right now, the most practical way to do this is to draw out a causal graph that where each of your features is a node in a graph structure, and an arrow says that this feature might influence this other feature. Each of these arrows is a potential cause and effect relationship. Once you've captured that, the second step is identification. This is now given a question that we want to answer. What is the effect of A on B? Identification is about finding the strategy to calculate that effect of A on B from your observed data. So given from the graph, the identification algorithm will read off the potential confounders. It will, depending on whether you want the direct estimate or the direct effect or the total effect, it'll take care of mediators and will give you the causal estimate that you care about. Cool. The statistical estimation step is about statistical estimation. There are a large number of these methods, each one of them appropriate for different scales of data, different kinds of data like categorical, binary, continuous, etc. And then validation and refutation now is where we go back to all the assumptions we've made through this process. What did we declare when we were modeling the assumptions? What did our identification algorithm assume? What did our statistical estimator require? And it's just keeping track of these and making sure that it's easy for you to test the ones that are testable, to refute the ones that maybe you can't validate, but you could prove them wrong if you see the right signals in your data, or to run a sensitivity analysis where you say, hypothetically, if there is, say, an unobserved confounder, how big does that have to be to mess up my results, to reverse my outcome, for example? And all of this now is intended to give you a better confidence in the output of your whole analysis process.
Nice. So let me try to restate those back to you in my own words to make sure that I, and therefore hopefully many of our audience members, get it. So the 4 steps of causal inference are first modeling our assumptions. So we create a graph that maps the potential causal relationships and other confounding variables and how they could relate to each other. The second step is identification. So actually, seeing if in that map, if there is actually a causal impact of A on B. I'm probably not describing that very well.
It's basically what's going to be your strategy. Do I use instrumental variables? Do I condition on some variables? There's multiple ways of getting at, how do I calculate the effect of A on B? And sometimes the answer is going to be you can't. You're not observing the variables you need to observe in order to really get at the result, the impact of A on B.
Excellent. Okay, so now I understand that step better. And then in step 3, that's where we can actually do some statistical estimation based on the approaches that we identified in step 2. So, and it sounds like there are a lot of different potential methods that we could use there, depending on the situation, depending on the size of the data set. Mm-hmm. And then finally, in step 4, we have this refutation validation step where we double check assumptions that we've made and results that we have, so that we have more confidence in the conclusions that we draw.
That's right.
Cool. Yeah. That sounds crystal clear to me now. Brilliant. So how and why will these 4 steps of causal inference impact machine learning? So it seems like, and maybe this is part of why you're so interested in this field in general,
Mhm.
It seems to me like there's a lot of discussion now about causal machine learning,
Mhm.
but we're still in the infancy of it being applied. So, yeah, again, how and why do you think these four key steps of causal inference will start to impact machine learning more and more?
Well, I mean, so stepping back, I think when we talk about conventional machine learning, the place we talked about how it looks for patterns, and sometimes those patterns fail, change, and then the machine learning model fails. The the place where that's most, I think, pernicious is in when you use machine learning models to help drive decision making applications. And the reason is that oftentimes the machine learning model drives a change in a decision making policy. That decision making policy changes the environment, changes the data distribution of the data patterns that the machine learning model then sees the next round around, which means that now your machine learning model is probably going to fail
Mm.
because of that data distribution shift caused by your new decisions and actions. And so the from like an application point of view of where can we use machine learning, my hope is that by moving over to causal ML models that are focused on the cause and effect relationships, that will now be able to apply ML to these decision making situations much more robustly.